Hi everybody, in case you don't know me, I'm Theo, mission lead for Space Microbiology, former co-director of outreach and operations. In terms of the Space Symposium poster, I just put our sample one here for Space Microbiology. A lot of people here have probably looked at an academic poster, seen an academic poster presentation, all of that. I know that in our mission, Minju mentioned, that new members should try to present. A poster is both a great way of demonstrating everything that you've learned and done throughout the year, but also deepening your engagement with that content if you joined a mission more recently or something else. So, I think everything's pretty clear as to what's expected on the poster, but in terms of doing a good poster presentation, there's two pieces of advice that I have, or two pieces of extra preparation. The first is that you prepare a 1 to 2 minute pitch, a 1 to 2 minute narrative arc that flows through different components of the entire poster, and make sure that you are the center of attention for whatever's happening, rather than the text or even like the pretty images. They're nice, there's bacteria, it looks space related, or at least science related, but you're the focus. And you're the person who they want to come and talk to, and who's going to provide that compelling narrative, more so than any of the individual sentences. What the purpose of the sentences or the images, is to hook the people in, right? If somebody comes with a biological focus, they will see the bacteria, and they will come to look at the poster. If somebody knows or sees the word quantum, we have the word quantum somewhere in here, and they're like, oh, I'm a quantum physicist, they're going to come over and talk more. And in that vein, for every sentence that you write, you should try and know one more key fact about it, so you're able to take that extra step further when they ask a question. So I don't need to know everything about quantum mechanics or how density functional theory works, but I need to know one cool fact when I'm presenting, so that when I get that question from the person who's really interested in density functional theory, I'm going to be able to tell them that and explain why they should still be interested in this work and how it applies to what we're doing. And if they do happen to be an expert in density functional theory, then that might be a good time to recruit them for the mission, because that would be very helpful for us. So, in that way, you can both feel extra prepared and be able to keep up the conversation with everybody who's interested, no matter if the parts of the project that they're asking about weren't the parts that you weren't specifically involved in or working with. So, okay, this is Space Microbiology. Welcome, welcome, welcome to the poster. Our mission objective, well, we explore all kinds of biological and chemical concepts in space. And this year, we've had a specific project focus. We are basically trying to enable long-term spaceflight habitation, like killing bacteria. But in spaceflight, bacteria are able to grow in much larger biofilms, or they're able to become more resistant to antibiotics through unexplored and unknown mechanisms. Our whole project is to basically use these zinc oxide nanoparticles in order to enhance the efficacy of antibiotics that are commonly utilized in space and brought here. Actually, the first infection of an astronaut occurred on the Apollo 13 mission. It was a Pseudomonas infection. We got it in space because the capsule kind of blew up, or at least parts of the capsule blew up, and some of the heating system went down. So there was no heat, and as a result, the astronaut got a Pseudomonas infection. They tried this very antibiotic, ciprofloxacin, against it in space, because that's what they had with them, and it failed. Now, of course, the bigger problem was getting them back onto Earth, and luckily they did that safely, so they were able to treat them going back on Earth. But if we're going to go to the moon, if we're going to go to Mars, if we're going to go to any of these other places, we really need antibiotics that are going to work, because we can't just bring them back. So this project is looking at chemical ways of enhancing the efficacy of antibiotics. We're using the same ciprofloxacin in our experiments, and we're trying to characterize it through a variety of computer science simulations, physics simulations, chemical, biological experiments, in microgravity simulation environments that our engineers are building, and that we'll get to use at the Jet Propulsion Laboratory in California. I look forward to your questions. Thank you.